Students, we are given the question. We are expected to find the equation of the tangent and normal to the curve y equal to x squared positive 3x negative 2 at 1, 2. Now, we can simply go ahead and do this question. Just find the equation of the tangent and the normal. But what I wish to do is I would like to show you all how to draw this graph. Okay. And then find the equation of the tangent and the normal. Now, foremost, from this equation, this is the equation of a parabola, okay? And the shape of this parabola is U-shaped, right? Now, the reason being, the coefficient of x squared, which you see there, actually the parabola is of the form y is equal to ax squared positive bx positive c. The coefficient is 1 there, and which is clearly greater than 0. Now, since it is greater than 0, it is going to be U-shaped. So, first point, it is the equation of the parabola. Second point, it is in U-shaped because the coefficient is greater than 0. The third point, we need to draw the parabola. Now, for that, foremost, we need to find the Y-intercept. Now, to find the Y-intercept, we put x is equal to 0, okay, into this equation. If I were to take this as 1, we put x is equal to 0 in 1. So, when we do that, I get y is equal to 0 squared positive 3 times of 0, negative 2, which is equal to negative 2. So, the y-intercept is going to be 0, negative 2. So, this is the third point. Now, the fourth point is we have to find the x-intercept. Now, how do we do that? For that, we take y is equal to 0 in 1. So, the equation 1 would be x squared positive 3x negative 2 is equal to 0. Now, if you were to use the quadratic formula, then x would be equal to negative b, that's going to be negative of 3 plus or minus root of 3 squared negative 4 times a times c. So this is going to be the equation 2 times of a, so which can be rewritten as negative 3 plus or minus root of 3 squared is 9, negative times negative will be positive, 4 times 4ac, right? So 4a is 1 and c is negative 2. So that's going to be 4 times 2 is 8 divided by 2. So that would give me negative 3 plus or minus root of 17 divided by 2. So 2 roots would be there. So I'm using the space here. So x1 will be negative 3. Now root of 17 would be approximately 4. Okay, approximately 4 point, because root of 16, we know square root of 16 is equal to 4. So square root of 17 would be approximately equal to 4 plus something. Now, if I were to take that, let me assume the value of root 17 to be the following. So if we were to take root of 17 to be approximately, say, some 4.1, I would have here 4.1 divided by 2. So that's going to be negative 7.1 divided by 2, which is going to be negative 3 times 2 is 6, carry 1.5. So 3.5. Negative 3.5 would be one root. The next root would be negative 3, positive 4.1 divided by 2. That's going to be 1.1 divided by 2, which is 0.5. Right, 0.55 approximately. So there are 2 roots we have got, 0.55 and negative 3.5. So next we have to find the axis of symmetry. Okay, axis of symmetry, that is given by the formula x is equal to negative b divided by 2 times a. Now clearly from here, a is equal to 1, b is equal to 3 and c is equal to negative 2. If I were to substitute that, x is equal to negative 3 divided by 2 times a, I would get negative 3 over 2, which is negative 1.5. So x is equal to negative 1.5. This is the axis. Okay. Now to find the vertex, we substitute x is equal to negative 1.5 in 1. Okay, so that is how we would get the vertex. So that is going to be y is equal to negative 1.5 squared positive 3 times 1.5 negative 2. So this 15, that's 1.5 squared, would give me 2.25. Okay, so this is going to give me 2.25. Of course, it's a positive sign. And this is negative 1.5, right? So that is going to be 45. So negative 4.5. And followed by negative 2. Now, this is going to be 2.25 negative 6.5. So if I were to subtract this, I've got 6.5 and I need to subtract 2.25. This is going to be 5, 4, 2 point and 3.25. So I'm going to get negative 3.25, my y value. So therefore the vertex for this parabola is going to be negative 1.5 comma negative 3.25. So we have got the following information. So this is another information. So to begin with, just to reiterate, we have got the first information here. Y-intercept we have got, and this is X-intercept we have got, and then we have got the axis of symmetry, that's negative 1.5, and the vertex. So suppose we were to draw this graph, the graph would be something like this. So let me show that to you all. Now the y-intercept is negative 2. So if this were to be negative 1 and this is negative 2, so the graph is cutting the point, the y-axis and the x-axis. Y-axis has negative 2. Now we don't know the x-intercept, okay, but we have found the x-intercept. So x-intercept value is negative 3.5. So if I were to take this as negative 1, negative 2, negative 3 and negative 4, negative 3.5 would be somewhere over here. This is one intercept, x-intercept, and we got the another x-intercept, that's going to be 0.5. So if this point is going to be 1, if I were to take this as 1, 0.55, that point would be somewhere over here. Okay, so I've got a point here, y-intercept, x-intercept, and then the axis of symmetry. The axis of symmetry has been found to be as negative 1.5. So if this point is negative 1, 1.5 will be over here. So the axis of symmetry, you have to draw this line, negative 1.5, this would be going like this. And the vertex, negative 3.25. So if this is negative 2, and if this is negative 3, and this is negative 4, 3.25, negative 3.25 would be somewhere over here. So this will be the point, negative 3.25, and that occurs exactly at negative 1.5. This is the x coordinate and this is the y coordinate. So we have to draw the graph. So if we were to draw the graph would be something like this, hitting the point here, rising up, hitting the point at y-axis and then moving up. Okay, now the graph wants us, okay, it moves up. So we are expected to find the tangent at the point 1, 2. We are expected to find the equation of the tangent at the point 1, 2. So if this point is 1 and this point is 2, so we are asked to find the equation of the tangent at this point. So there is going to be a tangent, at that particular point, and we are expected to find that. So if we were trying to mention this point as 1, 2, the tangent is going to be hitting the point, just touching the point. Okay, it will just touch the point and move forward. Okay, it won't make contact anywhere else. So that means the curve would be away from the line. The line will not touch the curve, but it will touch this curve at this particular point. So that is the visualization you need to have. However, we are expected to find the equation of the normal. Okay, we are asked to find the equation of the normal. Okay, so the normal will be hitting the line. In other words, it will be hitting the point perpendicular. We don't know where it hits, but we know that it will be perpendicular. Okay, this hit will be perpendicular and this will be 90 degrees to the tangent. Okay, we are expected to find the equation of this line and the equation of the tangent. That is the requirement. The most important aspect is I just wanted to show you how the graph is drawn. You don't have to draw the graph. Okay, in your examination, you don't need to draw the graph. You just need to work the question out. Now, we are given, what are we given? We are given that y squared positive 3x negative 2. This is given. Foremost, we have to differentiate this with respect to x. We got to find dy over dx. So dy over dx is going to be differentiate x squared, you get 2x. Differentiate 3x, you get 3. Now, we are expected to find the tangent at 1, 2. So that means you got to substitute 1 for x. So that's going to be 2 of 1, positive 3, which is going to be equal to 5. So this is what you have got. So what is this? This is nothing but the slope. Have that in mind. Now, this is the slope of the tangent. Okay, slope of the tangent. Okay, so m is equal to 5. That is the slope of the tangent. Okay, positive 5. Now, the slope of the normal, will be equal to negative 1 over m. That's going to be negative 1 over 5. This is the slope of the normal. This is the equation, standard equation. Now, having obtained this, now let us obtain the equation of the tangent. Okay, equation of the tangent is important. Now, equation of the tangent is given as equation of tangent is y negative y1 is equal to m times x negative x1. Now, we are asked to find the tangent at 1, 2. So that means this is x1 and this is y1. So if you have to substitute, you get y negative 2 is equal to 5 of x negative 1. This is y is equal to 5x negative 5. I'm moving this negative 2 to the other side. That become positive 2. So y is equal to 5x negative 3. This is an equation. So however, I can rewrite this as 5x negative y negative 3 is equal to 0. This is the equation of a tangent. This is one solution that you have got. Now, to find the equation, I'm using the space here just for sake of continuation. Now, equation of normal, okay, to find the equation of normal, you got to substitute, you got to use the formula y negative y1 is equal to negative 1 over m times x negative x1. Okay, this is the value you got to use, or this is the equation you got to use. So if you are going to be using it, now I want to use the space here. If you're going to be using it, you will add y negative in place of y1. I would be substituting 2, so is equal to, in the place of negative 1 over m. So now negative 1 over m is going to be negative 1 over 5. So that's going to be negative 1 over 5 times x negative x1 is going to be 1 there. So that's what you get. So if you were to cross multiply this, you get 5 times y negative 10 is equal to negative x positive 1. If I were to bring the x to the left, that's going to be x positive 5y. Negative 10 there, you bring it down, it will become negative 11. So negative 11 is equal to 0. So this is the equation. This is the equation of the normal. Okay, equation of normal. Okay, so in the diagram, that equation would be this. This is going to be, the equation would be x positive 5y negative 11 is equal to 0. This is that equation that we want. So that completes the solution for this question.